Our advanced statistics class here at the Battle Creek Area Math and Science Center is going to test a well-known myth. Does toast land butter side up or butter side down most often? To test this myth, we are going to drop various types of bread from two different heights, the table and the countertop. The results of these tests and some statistical analysis will bust this myth.
When dropped from a stationary position, the toast only has the force of gravity acting on it. This means it will fall the way that it was originally held, and it will land butter side up, assuming it was dropped butter side up.
The thing that causes rotation is torque. Torque is found by multiplying the force perpendicular times the lever arm. When the toast is pushed off the table or countertop, there will be torque acting on it. As you can see right here, center of mass, when part of the toast is over the table, force of gravity is acting on that side of the toast, but there's no normal force to counter the force of gravity. While over here, the normal force and the force of gravity cancel each other out, so there's no torque. But the torque caused by the force of gravity causes the rotation, and therefore it flips and lands butter side down. Now, the only thing that stops the rotation is the ground, so depending on how high you drop it or push it off, how high the tabletop is may influence how many flips. So it may land butter side up or butter side down.
Now we are making an assumption that the butter is spread evenly on the toast.
Up.
Down.
Really? Up.
Conclusions can be drawn from the data collected in an experiment, and statistics help show the significance of the results.
Without statistics, we won't be able to prove how significant our data is or how likely the events that occur happen will be.
Now that we have all of our data, we can use statistics, namely the z-test, to analyze our data. First, when we dropped the toast, nothing interesting happened because a toast that is dropped butter side up will tend to stay butter side up. So the interesting thing started happening when we began to push the toast with our little car. Vroom!
When you look at the control toast with just the mark on top where we would have buttered it, it had no difference than when we actually buttered the toast. So that means that the butter had no difference in the way the toast acted when it fell.
Between the heights, there was indeed a significant difference.
When you looked at when the toast was pushed from a table, less than 50% of it would landed butter side up.
In contrast, when the toast was pushed from a countertop height, more than 50% will land butter side up.
In conclusion, we can say that butter had no effect on which side the toast landed on.
The only factor that affected which side the toast would land on was the height.